right, good day, everyone. We get started in 1 minute. I just want to wait for everybody to join the class. Okay, so we'll get started, right? In terms of reviewing for the first exam. Okay, so yep. Okay, any questions before we get started? All right. Okay, so let's go to the Blackboard and then let's open the review sheet. I hope all of you guys get a chance at least look at the questions before I go over all the answers for those. And Friday, right? 11:10, you start taking the exam number 1 or test number 1. Okay. And also, after I finish reviewing today, I'm not going to go over any new content. So if you have any question from homework, I will answer all of your questions from homework assignment to help you complete your homework assignment. Okay, so let's look at the question number 1. Okay, so question number 1, determine whether the following are the linear function. Okay. Share the screen with you. Here you go. Okay. So basically, in order to determine whether or not they are linear function, you just basically solve for y, right? So for 1a, you write an equation. And then also combine the like terms on the left and right. On the right hand side, we have like terms. So combine those. 5x equal negative 11y, adding 7x minus 8. Then from there, we're gonna move 11y to the right. So adding 11y. Notice that we cannot combine the x variable with the y variable, right? Because they are two different type of variables. So we keep as is. So you have 11y adding 5x equals 7x minus 8. Also, we do not combine 7x and 8 because they are different categories, right? Belong to different category, constant and a variable term. Now from there, we just subtract 5x, keep 11y on the left. Subtract 5x from both sides of the equation. Then we end up with 11y equal to 2x minus 8. Now the very last step, we're going to divide 11 across and cancel 11. We get a y equal to 2 over 11x minus a over 11. And this is exactly in a y equal mx plus b, right? In this form. And we know that slope here is 2 over 11. And y-intercept b is negative a over 11. Okay. Yeah, so this is definitely a linear equation. Yeah, it is. So you should answer that it's linear equation, right? Always give a summary, what you did, right? Okay. All right, and then part B, 1B. We get 3x squared plus 3y minus 2x equal to 3x. 3x squared plus 3x plus 3y minus 2x equal to 3x. 3y minus 2x equal to 3x. So very similar. We will isolate the variable term with a y. Okay, so that means we're going to keep 3y on the left, right? So we're subtracting 3x squared, adding 2x from both sides of the equation. So subtracting 3x squared, adding 2x. Okay. Then we cancel 3x squared, so 3y is by itself, 2x cancelled by positive 2x. So 3y on the left. On the right, we have negative 3x squared. And 3x combined with the 2x become 5x. Now, just like the previous one, we just divide 3 across, left and right. Cancel the coefficient 3, so y is by itself. So you get negative x squared, adding 5 over 3x. And we know that this is definitely not linear because the power here is not 1. So that it's not linear function. It's what we call a quadratic function, quadratic equation. So the answer is it's not linear. All right. Any question on this? All right. So we can move on to question 2. Okay, we have a following equation, and then you create a table with 5 order pairs and graph using any 2 of the order pair, calculate ratio of the change of the y to the change in x. Okay. The second page. There you go. So we are given this equation y equal to minus 4.1x, adding 18. Okay. Here, first of all, we're going to create 5 order pairs here. So we look at all possible x values we can pick. I guess I will just picking starting point 0, and I will use increment of 2. That means 2, 4, 6, 8. I use all the even numbers. And the good thing about this is we don't have to deal with the decimal numbers once we pick the even numbers. And let's calculate all the y values. So start with x equal to 0, then y equal to negative 4.5 times 0, adding 18. Then simplify, you get 18. That's y-intercept 18. And the second one, y equal to negative 4.5 times 2, adding 18. So negative 9 plus 18, that's positive 9. Okay, 9. And then y is negative 4.5 times 4, adding 18. So that's negative 18, adding 18, then get 0. And then 6y equal to negative 4.5 times 6, adding 18. And negative 4.5 times 6 is negative 27, adding 18, so the result is negative 9. Okay. And the very last order pair, y equals negative 4.5 times 8, adding 18. So this is negative 36, adding 18. So it's negative 18. Okay. So we have all these 5 order pairs. And second one, using any 2 order pairs, right? So I'm just gonna use these 2. First one and the third one. Use those 2 order pairs, calculate the ratio. So this is 0, 18, and then 4, 0. All right, so you label the x1, y1, x2, y2, and then use that to calculate this. It's basically we are calculating the slope. So 0, 18, and 4, 0. So the rate of change delta y over delta x, basically it's y makes x1, y1, x2, y2. So using y2 minus y1 over x2 minus x1. This is exactly the concept of slope. And we get 0 minus 18 over 4 minus 0. So that's negative 18 over 4. And that turned out to be negative 4.5. This should match with the slope from the original equation. And if you have the same result, that means you have the right answer. Okay, and that's question number 2. It's fairly straightforward. Okay, now let's look at the question number 3. It's applying the linear equation, linear model in this dosage case. Okay, so the dosage for machine medicine is linear with the weight of patient. Okay, there's a minimum dosage onto which is added per pound dosage. So you find the dosage at 1110 pounds is 48 milliliter. So here you go. So you have first order pair. So here variable X should be the weight of the patient. And the variable Y should be the dosage. Okay. And the weight of patient is pounds, right? LB. Okay. And the dosage is milliliter. So just specify those two units. And now we have two given order pairs. So we have first order pair is 110 pounds with 48 milliliter dosage. And the other one, brothers, dosage is 170 pounds with 66 milliliter. So basically we come up with the two order pairs, and from there we'll be able to find out the slope first for this linear model. So slope equal to y2 minus y1 over x2 minus x1. Again, we're plugging on the numbers, 66 minus 48 over 170 minus 110. And that's 18 over 60. And this turned out to be 0.3. That means it's 0.3 milliliter, right? If you put into the unit, milliliter per pound. So for a patient's weight increased by 1 pound, the dosage is increased by 0.3 milliliter. Okay, that's interpretation of this slope. Okay. Now, once we have that, then we can find out the equation of the line using the point slope formula. So using y minus y1 equals slope times x minus x1. So we have x1, y1, we have a slope. So we throw into this slope-intercept form, point slope form. So you get y minus 48 equal to 0.3 times x minus 110. Now we distribute it on the right-hand side. Y minus 48 equal to 0.3x minus 33. Now from there, then we just isolate the y value. Get y by itself by adding 48 from both sides of the equation. Now from there, we get equation, right? 0.3x adding 15. Okay. And if you want to specify this, slope is 0.3, y-intercept is 15. And probably you find the unit of B and interpretation of B. So unit of B should be milliliter, right? Unit of y-intercept B, which is 15, should be milliliter. So we're talking about 15 milliliter here. And then the meaning of the y-intercept B here is minimum dosage. Minimum dosage. And then PASI, what's the dosage for a 165 pound patient? So whenever you're using the model, so basically mainly use it to make a prediction about the unknown condition. In this case, X is 165 pound. It wasn't indicated in the question itself. So we use model. Once we have the model, use a model to find out the designated dosage. So now throwing this 165 for the X and get a Y value. So Y equal 0.3 times 165 adding 15. And 0.3 times 165 is 49.5. Adding 15. So this turned out to be 64.5 milliliter. So that means for 165-pound patient, the proper dosage is 64.5 milliliter, to be exact. And this is question 3. Any question on this? And question number 4. We have given 2 order pairs, and then you want to find out the equation of the line. So here we go. So we get a first order pair -5, 3. Second order pair 0, 12. And a second order pair actually is kind of special because when x equal to 0 here, that means we have y-intercept b, which is 12. Okay, so we basically find out y-intercept directly. So the only thing we don't know is the slope. So x1, y1, so y2. So let's use a slope formula to find out the slope, y2 minus y1 over x2 minus x1. Now plug in numbers, 12 minus -3. So be careful about the sign, right? The only careless mistake to occur, it will be the sign. Make sure you putting all the sign here needed. So 2 negative turn into positive. So on top is 12 plus 3. Okay, on the bottom is 0 plus 5. So it's 15 over 5. So that turned out to be 3. So now we know that the slope and the y-intercept both, then applying the slope-intercept form, and we get the equation of the line. Slope 3, y-intercept 12. So y equal mx plus b. It's y equal 3x plus 12. That's the equation of the line. Okay. Okay, then question 5. So this is about the cost, revenue, and profit functions. And this is pretty comprehensive question. So let's look at it one more time. So we have a manufacturing company, so produces 450,000 units for $650,000 and 750,000 units for $950,000. Each unit could be sold for $5.50. Find cost, revenue, profit functions. Find the cost of producing 500,000 units and then break-even point. Right. So first of all, we look at the cost function. So for cost function, we are given 2 conditions or 2 order pairs, basically. First one is 450,000 units for $650,000 cost. The other order pair will be 750,000 units, cost $950,000. Okay. Now, basically, we know we are given 2 order pairs, just like any other questions. So here, let's define x for the cost function. X will be the quantity produced, right? Quantity produced. And the y value should be, so here we're using C of x, right? It's cost function, so C of x is the cost of producing x units, right? C of x. Okay, cost of producing x units. So first of all, let's find the slope here for this cost function. So y2 minus y1 dividing by x2 minus x1. And plug in numbers, 950,000 minus 650,000 dividing by 750,000 minus 450,000. This turned out to be 300,000 over 300,000 in the denominator. So this cost will be $1 per unit, right? So this is what this is, $1 per unit. That's the cost. And from there, we also need a y-intercept to have the cost function. So we do y minus y1 equals slope times x minus x1. Then we have slope 1, and then x1, y1 is given, so let's solve for the cost function. So y minus 650,000 equals slope 1 times x minus 450,000. Okay, so we have y minus 650,000, x minus 450,000 on the right. Now we're adding 650,000 from both sides of the equation. I cancel that y equal to x plus 200,000. So here, and then we use a function notation, so y becomes c of x. So cost of producing x unit will be x plus 200,000. Okay, so we have that. So this is the cost function. And second one will be the revenue function. And each unit is sold for $5.50. So this is the revenue per unit. And we have X unit, right? So revenue function here should be 5.5 times X unit sold. Okay. And then the third one will be profit function. Profit function is revenue function minus cost function. I'm just throwing both equation 5.5x minus x plus 200,000. Then we distribute it in the negative sign. So I have 5.5x minus x minus 200,000. Now from there, simplify the profit function, we get 4.5x minus 200,000. And we have a profit function. Yeah. Okay, that's that. So that all three functions are properly set up. Now let's find the cost of producing 500,000 units. So we need to look at the cost function, 5.5 x plus 200,000, and they want us to find out the cost of producing 500,000. So probably when x equal to 500,000, the cost function c of 500,000 equal to x plus 200,000. So 500,000 adding 200,000. This cost is 700,000. So the cost of producing 100,000 units is $700,000. So that's probably, and part C, we have a break-even point. Okay, so break-even point, you can get it from the profit function, meaning when there's no profit equal to 0, that's a break-even point. Okay, so look at the profit function and set it equal to 0, right? Okay, so that means you put it right-hand side equal to 0, 4.5x, adding 200,000 equals 0. And I noticed that some of you guys made a mistake in your project number 2 in terms of finding the break-even point. You can go back and then fix it, right? In your project number 2. Okay, and then adding 200,000 from both sides of the equation. Cancel that, so we get 4.5x equal 200,000. And from there, we're dividing 4.5 from both sides of the equation to get a break-even point. So then that's approximate values. And you're dividing 200,000 by 4.5. And let's see what that is. 200,000 by 4.5. And this turned out to be 44,444.4. And then we usually run up, right? So it should be 44,445 units. To be conservative, you run up to the next whole unit. So make sure you can break even, right? Okay. So the break-even point is 44,445 units produced and sold. Okay. And all right, that is question 5 on a break-even analysis. Any question on this? And question 6. Okay. Again, it's another application problem of the linear model. Then we have this long-distance phone service. They have a base monthly charge and a per minute charge. Okay, back in the old days, right? So, and when you use 350 minutes in a month, then the total cost was $32.50. When you use 400 minutes in a month, the total cost was $36.50. And on the equation that allow you to calculate your phone bill, and then you need to come up with the equation first, unit of slope, unit of B, and then interpretation of B, and how much will your phone bill be if you talk for 711 minutes. So basically, let's make sure we know what X value is, right? It's minutes used in a given month. And then Y value here represents all the, you can also say cost function here will be total cost, total phone bill. In a given month. Once we define the both variables, both dependent and independent variables, now we can have a set up order pairs and then solve for the slope first. So first condition is 350 minutes of usage costs $32.50, and then 400 minutes usage cost $36.50. Okay. So that's basically putting into order pairs first, and then from there we calculate the slope. So this is x1, y1, x2, y2. So the slope here equal to y2 minus y1 over x2 minus x1. And we plug in all the numbers, work it out step by step. For on top, 4 on bottom is 50, and 4 over 50 should be 0.08, right? This indicates it's 8 cents per minute in terms of the variable cost, right? Because you can look at that base monthly charge as a fixed cost, and there's a per minute charge. This is what they call the variable cost. So every minute you talked, you pay 8 cents. That's what this means. And next step, find out the equation of the line, y minus y1 equal to slope times x minus x1. Now we know x1, y1, we know slope. Now let's throw into the this linear equation. and I get the equation. So y minus 32.50 equal to slope 0.08 times x minus 350. Okay, now we distribute it, combine like terms. So y minus 32.5 equal 0.08x, and 0.08 times 350 turn out to 24. Okay, and from there we just adding 32.5 from both sides of the equation. Yeah. And simplify y equal to 0.08x, 32.5 minus 24 is 8.5, positive. 8.50. And here we know that slope is 0.08 cents, 8 cents per minute. And then y-intercept B here is $8.50. And you can also call this a base monthly charge, right? It's $8.50 is base monthly charge. That actually answers the part 2, part B. So part B is the unit of slope. The unit of slope will be dollar per minute. Dollar per minute. And part C, the unit of B and the interpretation of B. Unit of B will be dollar. And then the interpretation is the base monthly charge. Okay. Base monthly charge. So that's part C. And then how much will phone bill you talk for 711 minutes? So right here, part D, x equals 711. And we plug into the original equation. So y equal to 0.08 times 711, adding 8.50. And this total cost, and again, let me put into the calculator. And that's $65.38 for total monthly charge. So the total monthly charge, total monthly bill for 711 minutes is $65.38. Okay, any question on this? Okay, so let's move on to question 7 now. Question 7. Create a table of order pairs and graph them. So you have two exponential functions listed here. I'm going to graph each one of this. Okay. The first one is f of x equal 3 to the x power, and okay, f of x equal to 3 to the x. Okay. So here we need 5 order pair minimum, right? Minimum 5 order pair. We can pick the usual numbers we use, right? From -2 all the way to 2, -2, -1, 0, 1, 2. And calculate the y values for each one of these. So f of -2 is 3 raised to -2. And 3 raised to -2 is like 1/3 squared, right? That's 1/9. According to calculator, it's approximately 0.11. Okay, run it to 2 decimal place. Usually it's more convenient. And f of -1, it's 3 raised to -1st power. It's 1 over 3 to the first. It's 1/3. Approximately 0.33. As you can see, tripling because the base is 3. Okay. So the base determines how rapidly the exponential function increases here. F of 0, it's 3 to the 0 power. 3 to 0 is 1. Right? Any number raised to 0 power is 1. And then f of 1, 3 to the first, 3. F of 2, it's 3 to the second, 9. And then we have all the order pairs. First order pair, -2, 0.11. Second one, -1, 0.33. Third one, 0, 1. Fourth one, 3. Last one, 2, 9. Okay. Now we're just going to graph on the side. So we just need 9 units right on top. And then x-axis is what we call a horizontal asymptote here. There's no transformation here occurring. That means x-axis is the horizontal asymptote. Okay, so now we change to different color to graph it. Okay, so first order pair, -2. So we get -1, -2, 9. And then 1, 2. On a vertical axis, the maximum is 9, so we need 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And mark all those important numbers. 3, 1. Okay. Now applying all those order pairs. -2, 0.11. 0.11 is 1/9, so this is 1/3 right there. 1/3 is over there, and then 1/9 is way down, right? So somewhere here. It's very close to the x-axis, and then 0.11 is slightly above it. And then we have 0, 1. That's next order pair, 0, 1, 1, 3, and 2, 9. And you connecting those 5 order pairs and extend it, right? That's important task. Extending on both directions without boundary. No, I did not do well. Can I redo it? Okay. One more time, you're gonna connecting all those with a smooth curve and extending on both directions. Okay. And if you want to label this y equal to 3 to the x, you can do that. Okay. And from left to right, it's increasing because the base is greater than 1. Base is 3. 3 is greater than 1, so then it's increasing. We also call this exponential growth model. And the second one, let's look at the second one. F of x equal 2 times 1.5 to the x. So this one is slightly more complicated because we have a coefficient in front of the exponent. So B f of x equal to 2 times 1.5x to the raised to x power. 2 times 1.5 to the x power. And here you cannot multiply 2 and 1.5, right? You cannot simplify as 3 to the x power. It's different. Okay. Exponent and then the constant, they are separated, right? You cannot combine them. And similarly, we will need some order pairs, just like the previous one. So we're picking the same number from -2 all the way to 2, increasing by 1. And then let's find out all the x values. So after -2 should be 2 times 1.5 to -2nd power. And this will turn out to be 2 over 1.5 to the 2nd power. So 2 over 2.25. And let's see what that is. It's 2 over 2.25. And it's 0.89 approximately. So again, we don't get an exact answer, but we get an approximate answer, 0.89. First order pair. Second one, f of -1. So it's 2 times 1.5 raised to negative first power. So it's 2 over 1.5 to the first, 2 over 1.5. Let's be 1.33. Let's double check. 1.5. Yeah, 1.33 approximately. Look at that. And then the third order pair, f of 0. So now it's 2 times 1.5 to the 0 power. Any number raised to 0 power is 1. So it's 2 times 1. That becomes 2. Notice that now the intercept changes. The y-intercept changes to 2 because of this coefficient. Okay. And then f of 1, 2 times 1.5 to the first. So 2 times 1.5, that's going to be 3. And then the very last order pair, f of 2 times 1.5 to the 2nd power. So 2 times 2.25 and 2.25 times 2, that's 4.5. Okay, 4.5. Last order pair. Okay. And from there, we're going to graph it. Okay. Okay, so let's list all the order pairs 4.5. The first one, -2.89. Second one, -1, 1.33. Third order pair, 0.2, 1.3, 2, 4.5. Now again, we're going to graph it on the side, or you can graph underneath, no problem. And similarly, the horizontal asymptote, it's x-axis. Get different color graphing this. All right, so let's start plotting these xy values. -291, 1, 2. On the vertical axis, all we need is 5 units. So 1, 2, 3, 4, 5. So then 4.5 is right here, right in the middle of 4 and 5. Then we get a 3, 2, 1. That's more than sufficient. Then we start plotting this. -2.89. One here, 0.89 is quite close to 1. Right here. And then -1 corresponds with the 1.33, 1/3 of it. So it's above it. And then we get 0.2, next order pair. And then 1, 3. And then 2, 4.5. And from there, again, we're going to connect it with a smooth curve. Extend it on both directions if you want to. And this one is a lot smoother, right? It doesn't increase that much compared to the previous one because the base. If you compare the base, base is only 1.5, and then the base for the previous one is 3. So the bigger the base, the faster it increases from left to right. So here we have 2 times 1.5 to the x. Okay. And make sure you know this curve doesn't cross the x-axis, because x-axis or horizontal asymptote. So any question on the graphing part? All right, let's question 7. Question 8. Also, we have this population in Zimbabwe, where it was 12.7 million in 2004. The growth rate is 1.2% per year. What would you expect population to be in the year 2100? So that's the question. So using the exponential growth model to making prediction about the population. So this model comes with nt equal n0 times e to the rt kt. And in order to use a formula, we need to know something, right? At least three things out of 4. But there are 4 variables here. So here we're assuming in 2004, that's where the initial population occurs, also on the initial condition. And that means n0 equal to 12.7 millions. Keep as is. And also we know the growth rate. Annual growth rate is 1.2%. It's 0.012. And then we also know the time t, because between 2100 and then 2004, that's 96 years. Okay. So we know 3 things. Now we just throw all 3 numbers into the formula. nt equal to 12.7 millions times e raised to k is 0.012 times 96. And if you want, you can simplify 0.012 by 96. Turn out to be 1.152. Okay, so this is 12.7, and you can omit a unit if you want to, right? Unit is not, you put a unit at the end. E raised to 1.152. And then that gives us nt should be approximately. And similarly, we run into 1 decimal places, so 12.7 times e raised to 1.152. You should also try in your calculator or Excel. Make sure you know how to input this. Okay. So the answer is 40.2, approximately 40.2 million. Okay. So by 2100, by the year 2100, population will become 40.2 million. Okay. By year 2100, population to double, population of 40.2 million. Will be about 40.2 million. In terms of rounding, right? If the initial population was given in 1 decimal, and then you can run to your population, ending population also in 1 decimal. So we keep it consistent here, right? If you're not sure, how would you run it? You just follow the initial population here given in the question. And that's question 8. Question 9. We have this, Haiti has a population 8.1 million in 2004. The population is expected to grow to 20.0 million by 2070. And what is the growth rate? And again, we have some given conditions. N0 is given 8.1 million in 2004. Expect to grow to 20 million. That means NT is also given 20.0 million. And time T is given between 2070 and then 2004. There are 66 years. 66 years. Now they want to find out the growth rate, right? K. So K is not, no, let's solve for it. And right here, so let's plug into the formula NT equal N0 times e to the KT. NT is 20.0 million. And you can omit the units, right? Because unit will be canceled later. So omit the units. It's easier that way. 8.1 times e to the t is 66 is k times 66. Then reverse order first. 8.1 times e to the 66k equal to 20.0. And from there, we just get rid of the coefficient first by dividing 8.1 from both sides of the equation. Cancel 8.1, we get e to the 66k equal to 20 over 8.1. And you can leave as is, right? It's better to leave as exact number. So we leave as exact number. So taking ln from both sides of the equation. Ln from both sides of the equation, 20 over 8.1. Now simplify ln and e, they offset each other. 66k remains ln of 20 over 8.1. Then you get k, we divide 66 from both sides of the equation. Now k is by itself. And typically we run it to 4 decimal places before turning to percent. So let's see, ln 20 over 8.1 and dividing by 66. And this turned out to be 0.0137, 0.0137, and that's approximately 1. If you run into percentage, it should be 1.37%. Annual growth rate, right? 1.37%. Okay, so that's question 9. And then the very last review question: what is the doubling time? A population that grows from 35.6 million to 55.6 million in 25 years. So the first thing here is, there are 2-step procedure. First step is find out the annual growth rate K first from the given condition, right? So N0 equal to 35.6 million and NT equal 55.6 million and T is 25 years. So from here, we will be able to find out K first. And once you know the annual growth rate, and then we will work on the doubling time. So that's solve for K, just like the previous question. So NT equal to N0 times e to the KT. And throwing on numbers, 55.6 equal 35.6 times e to the K times 25. And reverse order, we get 35.6 times e to the 25k equals 55.6. Now, dividing 35.6 from both sides first. So we cancel coefficient. The e raised to 25k, it's equal to a quotient on the right. 55.6 over 35.6. Again, I leave as is. Now from there, we're taking the LM from both sides of the equation. simplify further, 25K is going to be equal to ln of 55.6 over 35.6. And then the very last step, dividing 25 from both sides equation. Case by itself. And here I'm going to keep as many decimals as possible because this is not a final result. So we do not run it yet. Not until we get to the final final step, 55.6 over 35.6 divided by 25. And this is 0.017833503. So I copy the entire decimal places to be more accurate, right? Okay, so we have the K value. Now we look at the doubling time. Okay, so second step. So this is step 1. Step 2, it could be tripling time, right? In your exam, maybe it's asking you for tripling time, meaning it becomes 3 times as much. And the easiest way to tackle this is you're assuming N0 equal to 1 unit, right? Doubling meaning NT will become 2 units eventually, double the population. Then we know the K. We just calculate that, 0.01783. 3503. Okay. Now from here, the only thing we don't know is T. So we're going to solve T. So now I'll throw into the formula here. NT N0 times e to KT. Then we're going to throw in all the numbers here. 2 unit equal 1 unit times e to the KT. And the good thing about using 1 and 2 is very small number. Also, the 1 you can omit it. So it makes calculations so much simpler. That's T. Okay. And from there, reverse order, we get E raised to 0.017833503 T equal to 2. Now we're taking the LM from both side equation one more time to get rid of the base E on the left. Equal LM of 2. Okay. Now LN and E offset each other, so we end up with 0.017833503 T equal to LM of 2. You just divide both side equation by this number. Then we get the final result. And let's see what the time is. You can run it to 1 decimal place in terms of year. And let's see what that is. ln of 2 dividing by 0.017833503. And this turned out to be 38.9 years, approximately. Okay. And if you want to turn this into, I'm going to do this one more time, right? I'm going to turn it into years, months, and then days. So you're going to do 38.9 years. That for sure is 38 years. And 0.9 times 12 months, that's 10.8 months. So 38 years, 10.8 months. I'll break down further in terms of decimals. So this should be 38 years, 10 months, and adding 0.8 month, 30 days. 0.8 times 30 days, and that would turn out to be 24 days. So this is 38 years, 10 months, 24 days. And if you really want to break it down into a detailed years, months, and days, and that's how you do it, right? Start from the very largest unit and keep breaking down until you reach the lowest unit, which is days. Okay. Any question on this?
Professor, do we
Go ahead.
this way on the test?
Yeah, Alexander. Yeah, so your actual exam will look very similar to this. Okay, so if you feel comfortable doing the review sheet, that means you're ready for the actual exam number 1.
Okay, and do we have to break down like the years like you did here?
You can do it for a small bonus point if you want to do it.
Okay.
All right.
I have a question, Professor.
Sure, definitely.
So
all right.
the exam is going to be like the review sheet you gave us,
Yeah.
and will we be doing it on Excel?
Yes, you can do
the
it.
problems that you gave us for the exam, we'll be doing it on Excel.
Yep, you can do it in Excel or Word, whichever you prefer, right? Word or Excel, you have 2 choices.
But if we do it on Word, it would be written like you're doing it now.
Yeah, also Word, you can insert equations. I'm gonna show you something really quick from the Word. It's called equation editor. It's quite handy too.
Oh, okay. Yeah, because I was having a little difficulty with the assignments from like all the chapters, because sometimes on Excel, like when I tried to write out the equations, Excel thought I was using a specific function when I was just trying to write out the problem. So it would try to insert a formula when I wasn't using a formula and I was just writing down. So I just didn't know if there was like another option instead of Excel to resolve the problems.
So in the Word, right? I can also show you. Can you see the Word right now?
Yeah, I can.
Okay, very good. So here, you see, you can type in a text, right? Let's say the population, there's no problem. All this, it's doable. Let me make it slightly bigger so you can see that.
Also, if you're trying to do it in Excel and it keeps like changing because that happened to me too on some of the problems, all you have to do is type an apostrophe before the equation and then it will like take out the apostrophe and leave what you typed.
Yeah.
Oh, okay, thank you. I was putting in like parentheses around the like plus signs so that it wouldn't think it was a formula, and that worked, but it kind of seemed a little disorganized and I didn't want the professor to get confused.
Yeah, thanks for thinking about that. And then your classmates definitely provide a solution, so that's good. And also another option is if you insert, there's the equation here, and there's the equation editor. I know it takes some time to get used to this. Let's say you want to calculate ln of 2. You can definitely type in that and dividing by. You can also have this kind of but you take some time to type it up, right? Just like Excel, but I think Excel probably is slightly better because you see ln of 2 and then you can put in the number which did 1783335. No, 833 yeah, 833503. Okay, so you can type something like that and then get answer, right? Approximate answer from there. So equation tools. Here there's approximation sign. All of these symbols you can find on the sidebar here. And so this is another option. So totally up to you. If you feel like you are more comfortable using the Word, use the Word. But since we are practicing a lot of Excels, I would assume most of you guys feel comfortable using Excel, right? So totally up to you. So
I like using Excel. I just if we're using Excel, I didn't know if you wanted us to write out the whole process of like moving numbers, for example, like the first problems that you have to find M and B, like the slope, and then I didn't know if you wanted us to simplify the formula by each step in Excel, or you just wanted us to like do that manually, and then there's just like write in the answer and why it was that.
I would like to have more details.
Okay.
More
Okay.
details, the better it is.
Yeah, like
And
how we did it.
let me explain it to you, right? So in a case, you know, you made a mistake on the final answer, but if you show all the steps, I will give you partial credit for each step
Okay.
you show, even though your answer is wrong, but you still get
Okay, yeah.
partial credit. But if you do not show any step, right, just put on the answer, then your answer is off, then you do not earn any credit for that, right?
Yeah.
Because, you
Makes
know, I
sense.
have nothing to go back or to keep check the progress.
Okay.
It's better to show all the details step by step, and then the more detail you have, the better chance you're going to earn more credit. You know, even though your answer is off, or maybe you didn't have the completely right idea to solve the problem. Like the question 10 is pretty comprehensive, so a lot of details. So if you get most of the details right, you get most credit. But if you do not show any details, then yeah, if your answer is off, then you lose all the points for that.
Okay.
Yeah.
And my last question is, since the exam's gonna be on the 3 Excel projects, are you gonna return Excel, like our Excel 2 and 3 project corrected to know, you know, if I did it right or if I messed up on ones, or should we just use the practice exam?
Yes, I can finish grading that by the end of today. So you can
Okay,
check
I
out
just wasn't sure of what I did, if I got some wrong or not, since
Uh-huh.
they're not graded, and I just wanted to know that. That'll help me study.
And then your Excel project has mostly are independent, right? Your exam question come from your homework assignment.
Oh, okay.
Yeah, so you
I
should
thought it was
focus
just
on more
me.
on the homework assignment. If you have anything you're not very clear, you can ask me right now. I'm more than happy to go over any homework question you may have and to help you, you know, prepare for the actual exam. But use the review sheet as a study guide, right? That's like the major contents or all the major topics will appear in your exam number one.
Oh, okay.
Yeah. Okay. All right. So any other question? Any logistic question before?
Professor?
Yeah.
Hi. I'm not sure if you had mentioned this before or anything. Would you be able to tell us like how many questions are on it or?
Yeah, definitely. 10 questions, right?
Okay.
Approximately 10 questions.
Okay.
Maybe 10, 11. Yeah, 10 questions, most likely. Yeah, and yeah, so it will be very similar to your review sheet. Okay. Yeah, any other questions or any question from homework, right? Let me know. I'll go over that in the class so you have more confidence, you know, in terms of solving each individual problems. No other questions. Oh, and if you need feedbacks about your project, you can stay after class, and I can give you some feedbacks if you feel like you may have some question from your project. Yeah, sure. Brianna.
Hi, yes. When is the project due?
I think, let me double check. I think the other two I extended a little bit, but I extended. I want to make sure everybody get a chance to revise it and then get a better grade. So let me quickly double check that. It should be due by the Sunday, I believe. But let me see. Submission. This is original due date, but I think I extended. Excel project number 1. Okay, so it's due by the 28th. But if you need more extension, let me know, right? I can extend a little bit further just in case you want to revise it. You didn't get a chance to revise it. I can let you revise it and then resubmit it.
Wait a minute, that says 2/28.
Yeah,
And
this
today's
is
March
project
3rd.
number 1. Yeah, this is Excel project number 1. And you did it a while ago, right? Do you need more extension?
Yeah, to my knowledge.
Okay. Okay, so I will extend it till Sunday. So does that work? Okay.
Sure.
Okay. So Sunday, right? I'll extend until Sunday. The second project, I believe, should be due. Did I extend it yet? No, I can also extend it till Sunday, just in case you want to revise it and get a better grade on it. Sure. And same thing for Excel project number 3. I'll extend it till Sunday. Okay. Yep. All right. Okay, so how about any homework questions?
I
No?
just have a question about the test.
Definitely. Go ahead. What's your
Would it be okay, like, if we can like write the question down on like a separate sheet of paper and then upload like pictures of our work, or does it have to be through Word or Excel?
picture of the
Like
Yeah.
if I like write down my, like if I do it like by hand, like do all the work
Okay.
and then like upload like photos of the questions in the work, or does it just have to be through Word or Excel?
that will work too, but you gotta submit it in one file, right? Do not submit it as a separate files.
Okay,
If you want to do that, fine. I'm okay with that.
okay,
You take picture of all your work and put it into one file, right? Submit it as one file.
okay,
You
thank
do
you.
that. Is that possible?
Okay, thanks.
All right, that works. Okay. Any other question?
Sorry, I have one more question regarding
Mm,
the
sure.
test.
Mhm.
How much time will we get? Like, how many minutes to complete everything?
About 100 minutes. Like 10 questions. You see, I finished the 10 questions in like 80 minutes. I also explained to all of you guys. So 100 minutes should be reasonable, right?
Yes.
Yep. So but if you, yeah, definitely 100 minutes should be more than enough. Yeah. Unless you need more time, but you gotta let me know after that, right? But I highly doubt it though. Okay. All right. If you have, how about the homework question? Any homework questions, or we can end the session? Okay, I have no new content today, so I guess if you have no homework questions, or if you have individual questions you want to ask me, you can stay after class, and I can talk to you on an individual basis. Otherwise, I talk to you guys on Friday then. Okay. So yeah, class is over. Feel free to go, right? Okay.
Thanks,
Thank
Professor.
you, Professor.
Thank you.
Bye. Thank you.
Bye, guys.
Thank you.
Okay, bye.
Are we meeting? Sorry, last question. Are we meeting on Friday or are we doing the test?
You mean, yes, definitely. We are meeting when you're taking the test. Yes.
Oh, okay, so we're gonna be connected on Zoom.
Yeah, we'll be connected on Zoom. Yes.
Oh, okay, well, we'll see you Friday.
Okay, talk to you Friday.
Bye.
Bye-bye, guys. Okay. Alonso, do you have a question, or you just want to, or I can hang up? Okay, so I guess you have no questions, so I will end the session.